usage of external interrupt 0 to toggle an LED on and off. What is the meaning of this? So we have to demonstrate the usage of external interrupt. Actually, there are four external interrupts are there in LPC 1768. We have to, that is external interrupt 0, external interrupt 1, external interrupt 2, external interrupt 3. And if any external interrupt occurs, immediately it will stop the normal execution, that is normal program execution, it will stop, and the control will go to ISR. ISR stands for interrupt service routine. Each interrupt, external interrupt service routines are written in different address. So whenever any interrupt occurs, immediately it will execute the ISR written for that. And after the completion of interrupt service routine, it will continue with the normal application. So in our college kit, actually there is a two buttons for external interrupt 0 and external interrupt 1. Okay, I'll show that. Whenever if you press that button, we have to, there is a occurrence of external interrupt 0, and immediately it will stop normal application and it will execute ISR return for that. So in the program part, actually the normal program, we are not writing anything. So that means it's a blank program. Simply assume that some program is running. In between that running, whenever it is running the normal program, you press that external interrupt button. So immediately, anyway, in our program, we are not writing any normal application. So it will go to ISR, where in the IS service routine, actually we are writing a, in the question, you can see that whenever external interrupt occurs, there should be a toggle of one LED. So in the ISR part, we are writing a code to toggle the first LED which is there in the kit. I'll show the connection of that. So this is the kit figure. Okay. This is the external interrupt, you can see here. Interrupts. External interrupt 0 button is this. External interrupt 1 is this. So if I see normal program, nothing is actually running in our program because we have not written any code for normal program. So this is actually program written for show the demonstration of external interrupts. So two buttons are shown to indicate external interrupt 0 occurs. So when you press this button, okay, so then immediately it will go to the ISR, where in the ISR interrupt service routine code is written to toggle this. Okay, this is, you can observe, this is connected to port 0 fourth pin. First LED it is connected to port 0 fourth pin. This is port 0 fifth pin, port 0 sixth, port 0 7, port 0 8, port 0 9, port 0 10, port 0 11. 8 LEDs are there. So you can see the connections details. So this is external interrupt 0. This is external interrupt 1. You can show two at a time. Okay, both you can enable, and both the demo you can show. For one, you can write a program to toggle this LED, and you can also write another ISR for external interrupt 1 also, and you can toggle any of these LEDs. If you want, you can do for this also. Last LED, 8th LED, which is connected to port 0 11th. Okay, and the code, if you go there, okay, first we have to check where actually in the LPC 1768 this external interrupt 0, external interrupt 1, external interrupt 2, 3 are present. External interrupt 0, external interrupt 1, external interrupt 2, external interrupt 3. So LPC 1768 has these four, no? So you have to search where these pins are available. So if you search that user manual, you will find here where actually these pins are available in pin select 4 register, pin select 4. So pin select 4, which pins acts as external interrupt 0? Port to 10th pin. port to 10th pin acts as external interrupt 0. It is an alternate function. It is not a default function. Default function is GPIO, because whenever you reset microcontroller, all the bits of 32 bits of pin select 4 contains 000 only. So 0th bit first pin select 4, 0 bit first bit, second, third bit, fourth, fifth bit, sixth, seventh, eighth, ninth, 10, 11, up to 31. All bits are actually 0. So all the ports, okay, port 2.0, first bit, second, third, fourth, fifth, 7, 8, 9, 10, 11, 12, 13, all acts as, okay, general purpose input output. That is a default function. Now actually I want alternate function. Port to 10th pin, it should perform alternate function of external interrupt 0. So then 21 and 20 pin should be 0 1. 0 1 means 21 is actually 0, 20 pin should be 1. Then it will perform external interrupt 0 pin. Suppose if you want to show second pin, external interrupt 1, then you have to configure here 22 and 23. 22 and 23 pin should be 0 1. That means 22 pin, this is 23 0, this is 1. So 22 pin, if you make 1, then external interrupt 1, actually port 2.11 works as, functions as this. If 20th pin is 1, port to 10th pin functions as external interrupt 0 pin. Okay. If you want to do only one, then only you make 20th pin of pin select 4 as 1. If you want to use only external interrupt 1, only 22 pin you make 1. If you want to show demo of both external interrupt 0 and external interrupt 1 simultaneously, 20th pin and 22 pin both you have to make as 1. So in the external interrupts, actually there is a register, EINT register. The register is associated with LPC1768 external interrupt register. So here you can configure different types. Okay, you can set the mode, whether it is a level triggered or edge triggered. By default, this external interrupt register, external ANT register also, all the bits are 000 only. So by default, it considered a level triggered. If you want, you can give externally, change the mode, and you can change that level trigger to edge trigger also you can change. So here we are using level trigger only, so that's why I'm not changing anything. The mode I'm not changing. And one more register we are using here, external int. So this is to uh, it will contain external interrupt flags for external interrupt 0 1 2 3. Whenever any interrupt occurs, and then external interrupt 0 flag will be set. So if you want to identify one more interrupt, these flag bits you have to clear it. Okay, always these flags we're going to check whether the interrupt occurred or not. Once it is occurred, it will indicate occurred. Then you have to clear that flag bits, then only you can recognize next interrupt. Okay, so this is external int. The 0th bit indicates external interrupt 0, 1 bit indicates external interrupt 1. These are the flag bits. Okay, 0th bit indicates flag bit of external interrupt 0, then first bit indicates the flag bit of 1, second bit indicates the flag bit of external interrupt 2, 3 bit indicates the external interrupt 3. But in the college kit we have only two buttons, no? So only external interrupt 0 and external interrupt 1 you can show the demonstration. Okay, so this is for mode selection. If it is 0, level triggered, 1 means it's triggered. So steps to configure the interrupts. Configure the pin as external interrupts using a pin select register. Okay, we have to select using pin select 4 register, I think, and clear any pending interrupts in external interrupts. If you are using first interrupt, external interrupt 0, then you have to clear by putting 0 here. by putting 0 here. You have to clear, sorry, not here, here. Extra length is 32-bit register 0 to 31. If you put this is here 0, then it is actually cleared. So clear any pending interrupts. Okay. Next to configure external interrupt as edge or level triggered using external mode register. So if you don't change this, by default it will be level triggered. And you can also check the polarity. So don't worry about, anyway we are not using these two. We are just clearing the flag bit, and we are calling NVIC enable IRQ. It is a case sensitive, so write properly NV capital NVIC. Okay. IC enable IRQ means interrupt request with IRQ number. So let us go to the code, demonstrate the usage of external interrupt 0 to toggle LED on and off. So we are writing a code to toggle the first LED, which is port 0. This is port 0 and fourth pin. So that is actually in the kit. It is this port 0, fourth pin. If you write port 0 11th pin, this LED is going to toggle. If you want to toggle this LED, you have to write 7 instead of 4 there, you have to write 7. So here I am showing the demo of 4. So port 0, fourth pin. So this is actually, we have to write, in order to toggle, we have to write ISR. This is a ISR. See here. This is service routing. Whenever interrupt occurs, ISR is handled. So that is called as is handler. So this is the ISR written for external interrupt 0. So void external interrupt 0 interrupt request handler. So it is case sensitive. Write properly, capital EINT. This is number, external interrupt 0 number underscore IRQ. I stands for interrupt, RQ stands for request. R are caps, IRQ, and handler capital H. It is a case sensitive, and these files are written actually in startup file, C file. In the C file, this function is there, so we are calling that function. So IRQ handler void. So under the IRQ service routine, we have to write a code for toggling that LED. So before we are clearing that interrupt, because whenever external interrupt 0 occurs, then flag is actually going to set, you have to clear. By writing 1 there, it is going to clear. So first you are clearing that external interrupt. So clearing external interrupt 0. Before doing what actually toggling of LED, in order to recognize one more interrupt, we have to clear that flag. So how to clear? LPC underscore SC. So SC means you can consider system call like that. So SPC underscore SC dash, this is not underscore, dash greater than mark EXTINT, caps letter, all are caps, and is equal to 1. So 0th, if you write 1 means actually 0th bit is 1. If you write 32-bit format, 0th bit is 1, so external interrupt 0 is cleared. If you write 1 here, second place, then at that is for external interrupt 1 clear. So 1 0 means 2 you have to write here. For clearing external interrupt 2, instead of 0001, you have to write 10 here. So that means second bit is 1. Then corresponding decimal number is 2. 10 means 2. Okay, for 1, last bit is 1, external interrupt 0. External interrupt 1 is this. External interrupt 1 is second one. External interrupt 2 is third one. External interrupt 4 is this one. So either you can write 1 here, 2 here, then you can write 4 to clear third one, to write 8. So 8 means 1000. Then it will clear external interrupt 4. But in the college kit, only 2 are there, external interrupt 0 and external interrupt 1. You have to write either here 1 or here 1. So if LSB is 1, you have to write here 1 as the decimal number. If the second bit is 1, you have to write decimal number as 2. Or you have to write 0x followed by this symbol only. So LPC underscore GPIO FIO pin value I am giving LPC GPIO general purpose input output port number 0 fast input output pin value are giving, and that pin value we are giving for uh, fourth pin we are making 1, and actually here it is XOR gate. This symbol is called as cap is XOR gate, so it will actually reverse the previous value. Okay, so it is nothing but toggling. If previous it is 1, it now it becomes 1, and 1 means it will become 0. So it will convert, or it will just toggle previous value. Okay, 0 to 1 or 1 to 0 it will convert. So for toggling you have to use XOR symbol. XOR symbol is cap. Okay, that is you will get by shift 6 button. Okay, in the computer shift 6 button, if you click you will get click like this cap. So this is the ISR. ISR means this part. We are writing code for this part. Toggling just now we written now, that is handler interrupt request handler part. So this normal program is running. When you interrupt, ISR written for external interrupt 0, that is ISR written for that one is interrupt request handler 0, that is going to execute. In this we are written the code to toggle the LED. Okay, now what is the main program you see here? In the main program, while 1 nothing is there. While 1 no statements are there. So in the main program we are not writing anything, because this program is to demonstrate usage of external interrupt. So in the main program nothing is there. So in the main program you have to do some configuration. So LPC underscore system SC dash greater than mark external interrupt 1. We are clearing external interrupt 1. If you want to clear both first external interrupt 0 and external interrupt 1, both you have to make 1 1. If you want to make only external interrupt 1 as clear, then second bit you have to make 1. Now here we are clearing only external interrupt 0. After that, this is to clear. Initially all the external interrupts are cleared. So next we have to configure, that means port that is pin select for 20th bit we have to make as 1, because we have to select this pin I showed in the beginning. So this part I am doing now. External interrupt 0, that is port 2.10th pin should work as external interrupt 0. So 20th bit of pin select 4, this you have to make as 1. So in that code we are writing that now. Okay, LPC underscore pin configuration pin con, all you have to write in caps, dash arrow mark pin select 4, 20th bit as made as 1. Next LPC underscore GPIO 0, we are putting direction, that is a port 0 fourth pin we are configuring as output. In the dir we are making 1, that means port 0 fourth pin is configured as output, and we have to call this function nvic underscore enable IRQ external interrupt 0 IRQ n also you have to write, and semicolon here. So you have to call, you have to enable this external interrupt. If you don't write this system, it will not recognize. So nvic enable interrupt request external interrupt 0. If it is for external interrupt 0, you have to write external interrupt 0. If it is for external interrupt 1, you will change this one to 1. And if it is external interrupt 1, this you have to change it to 22. Change this one to 22. Change this one to 1. Change this also to 1. If you want to enable both, you write here, here you have to write second bit so 1. Then you have to write 1 1 means 3. You have to write 3 here. Here you have to write 1 left shift by 20 or with 1 left shift by 22. And one more sentence, nvic enable interrupt request e int 1 underscore IRQ N also to write. And one more, this is the ISR for external interrupt 0. And one more, this part you have to write. Okay, wired into 1 IRQ except render, and there you can write toggling of some other LED. Okay, so main program is nothing. Okay, you in the output tab, go to options for output target, output tab, options for target, go for output tab, click on create X file, then build target, X file will be generated, then you can download using check the communication port number, then open Flash Magic and browse the text file, and you can download and program it. After program it, once your program is done, press this button. Once you press this button, if it initially if it is on, then it is going to turn on. If initially it is on, it will turn off. So once you press this, it will go to opposite state of previous. So that is nothing but toggling. Press and press. You have to press for some 10 millisecond like that. It is going to toggle its value. So this is for external interrupt 0. Similarly, I told no procedure if you want to enable second one, second bit should be 1. So you have to, for example, I will now explain how to do for second one. In order to toggle this, then you have to write there 2 because second bit is 1. And if you want to toggle 11th, this is a port 0 11th, that is the last LED, then you have to make these changes. Okay. So here you have to write second bit. Second bit means 1 0. Here you have to write 2. Here also you have to write 2 because second bit you have to clear once again. And here you have to write 1. External interrupt 1. Here you have to write external interrupt 1 IRQN. So in the ISR also you have to write void external interrupt 1 IRQ handler. And here also you have to write 1 0. 1 0 means 2. And toggling, if you want to toggle 11th last LED, pin number you have to write 11 here. And in the main program also you have to configure 11th bit of port 0 as output. If you want to show the demo of 2 simultaneously, you have to write 3 here, 1 left by 20, 1 left by R with 1 left by 22. Here 1 left by 4, R with 1 left by 11 because both LEDs you have to enable. And in the ISR, 1 LED you have to write in each IRQ. For external interrupt 0, fourth LED. One more same set of these 5 lines, 4 lines or 5 lines. One more set you have to write. There you have to write 1. External interrupt has 2 and LED has 11. Okay. This can see the video of the demo of IRQ already shared in the Google Classroom.